Okay, so this is our next problem. Top k frequent elements. What is given? We have given an array, okay, and we have given a k. So what we need to return? We need to return two kth most frequent elements. Okay, top k frequent elements. So we have one, two, three. Okay, now we need to return two two frequent elements. So what are the two frequent elements in this array? So one is occurring 3 times and two is occurring 2 times. So we will return this. Okay. Now we have given an array which contains one element and we have given k equals to 1. So one frequent element is 1 only. Okay. Now what are the constraints? So the constraints are num length is in the range of int only. Okay. Numbers can be in negative also. Okay. K is in the range of 1 to the number of unique elements in the array. Okay, so that is important one, and it is guaranteed that the answer is unique. Okay, so how to solve this problem? Let's discuss. Okay, so let's say we have given this array 1 1 1 2 2 2 3 3 like this. So it is given that in constraint it was given that answer will be unique. Answer will be unique. What does it mean? What does it mean? Let's say we have given k equals to 2. Okay, and the array is given as 3 3 3. Now what can be the two frequent answers? So either it can have 1 comma 2, and it can have 1 comma 3, and it can have 2 comma 3, and any combination of 1 2 and 3. Okay, so this is not there in our problem. Okay, it is given that answer will be unique, so there will be no ambiguity. What does it means? It means that we will be given a problem which only have one answer. Okay, so let's take this array. Now what is the problem? That we need to return the top k frequent elements. Okay, so we will have 1 and we will have 2 if k is equals to 2. If k is equals to 3, then we will have 3 also. But if k is equals to 1, then there will be no unique answer, because we can return 1 as well and 2 as well. So this will not be the case in our problem. Okay, now how to solve this problem? So there can be multiple ways to solve this problem, but I'll teach you the practice one. Okay, so what we can do, how to store the count of these one, how to store the count of these one. So a you can take a hash map. Okay, an ordered map we call in C++, right? In Java we called hash map. So this will be the element and this will be the count. Okay, so one's count is 3, two's count is 3, three's count is 2. Okay, and we know how to put values in map. Okay, we will iterate through the array and just put it in the umap of array of I plus plus. That's it. Okay, so we will take a unordered map or whatever data structure you want to take. We just need to take care of this count. Okay, this is the first step. Now we got the count. What we can do? We want top frequent elements. Okay, so top frequent, it can be converted as something like largest. Okay, so we want the maximum one. Okay, in this case we want the maximum one. Top frequent means we want the maximum ones. Okay, we want the maximum ones. So whenever we want the maximum ones, use min heap. Okay, I hope you got the intuition. Is the problem is top frequent? Top frequent means which we are using most of the time. Okay, whose counts are maximum. In the simple words, whose counts are maximum. Okay, so for maximum ones we can use min heap. Now what if the problem is least frequent? It can be the problem, right? If the problem is least frequent, that means we need the minimum ones. Okay, minimum count ones, minimum count elements. Okay, in that case we can use max heap for optimal approach. Okay, we can use max heap here also, min heap here also, Wherever we can use max heap, we can use min heap also, but we need to take care of time complexity. So here it will take order of log k time only. Okay, and log k, here it will take order of n log k. Okay, but if you use another one, if you use max heap here, it will take order of n log n. That will be similar to sorting, right? So we want to avoid the sorting part, that's why we are using heap. Okay, so the time complexity will be order of n log k whenever you are using such kind of problem. Okay, now how we can use this? Okay, so let's forward to this problem, top frequent. Okay, and try to solve the least frequent as well. Okay, this is in homework. It is similar, right? It is similar, just you need to change the heap. So we have elements in our map. Okay, we have elements in our map. Now what I can do, I can store this in priority queue, but in priority queue I will store only k size. Okay, we are using we are using min heap, so I will store only k size. Okay, let's erase this. Similar to kth largest in array, kth largest in string, whenever you will see maximum ones and you are using min heap, so what you will do, you will store the elements in k size heap. Okay, so we'll take a heap, it is k size min heap. So what I will do, I will just keep pushing the elements, okay, until it fills my size. So whatever conditions we keep on using in those problems will do the same. Okay, so what I will do, I'll traverse through map. Okay, and if my priority queue size is less than k, then keep on pushing in the map. Okay, whatever value at the map. Okay, and in else part what I will do, I will compare. So if my pq dot top, I want the maximum ones. Okay, so I will remove the minimum ones. If my priority queue top is less than my map element, okay, then what I will do, I will pop it and push it back. Same logic which we are using until now. Priority queue dot pop, and I will push the current element from map. Okay, current element, like this. Okay, so this is simple one, right? We can do this. So let's code this also. So what I will do, I'll take a int n equals to nums dot size, and I will take a priority queue. Okay, so in priority queue, basically what we need to take the count as well as the element itself, because we don't need to return the count, we need to return the element. Okay, so what we'll do, we'll take a pair of count as well as the element. Okay, so first let's take the unordered map. Okay, let's take the unordered map. Unordered map will be of int comma int. Okay, what it will store, it will store the element and their count. Okay, now we need to use both in priority queue. So what I can do, I can take a pair. Okay, I can take a pair. So let's take a pair of int comma int. Okay, and wherever we are using int, we will use pair int. Okay, so pair int comma int. Okay, and in greater we'll take pair int comma int int. Okay, pq, and this will also close here. So close the pair also, and here also close the priority also. Okay, so if you don't understand this, just take it int. Okay, just take int here. Okay, take int here, take it here, take it here. Okay, take it here. Okay, and replace this int with pair. Okay, so replace the int with pair, you will get it. Now I have taken the min heap. Of what it will store, it will first store the count and then the element. Okay, why we are doing this in reverse order, why we are not storing element and count pair? that you will get. Okay, now what I will do, first I will iterate the array. So let's take for auto it in nums, and what I will do, I'll put, either you can use for each loop or just I equals to 0, then whatever, simple for loop. Okay, so I will take a umap of it plus plus. Okay, now what I will do, I have taken the count in unordered map. Now I will put it in priority queue. Okay, so how I will put it in priority queue, just iterate through the map. Okay, let's say it and take the umap and pq dot push. We have taken the pair, so that's how we use pair. Okay, that's how we push element in pair. So take this curly braces, and first we will take count and then we will take element. Okay, but in map this was element and count. So what I will do, first I will put it dot second. Okay, and then I will store it dot first. So what it is storing, we are storing the elements count first and then element. So we are pushing all the elements in priority queue, but we'll check a condition, pq dot size. If it is smaller than k, then only we will push. Okay, otherwise what I will do, using the same condition. Okay, I will check I will check if element at pq dot top is less than pq dot top dot first. Okay, is less than my it dot second. Okay, so basically what we are doing, we are checking if, see the in pq the first is nothing but the count. Okay, so we are checking the count, and in umap we have count here. Okay, in second. So compare this. So what I will do, I'll pop pq dot pop, and I will push pq dot push it dot second comma it dot first. Okay, and at the end what I will do, I will just pop it out. So while pq dot empty, I will pop this out. I will take answer also. Okay, so let's take a vector int answer, and I will push all the elements in answer. Int current element, okay, will be pq dot top dot, we are storing element in second. Okay, so it will be second. See, to avoid confusion, just write in map, just write what is the order, element and count, and in priority queue, in comment, just write count and element, so that you can avoid the confusion. Okay, so my current element is in priority queue. I am storing the count first and then my element. Okay, now what I will do, I will push this current element in my answer. So answer dot pushback current element. Okay, and just pop it out also, pq dot pop, and at the end return answer. Okay, so first run this, then I will explain. Okay, so test cases are running. Let's run this. This is also running. Let's submit this. It is accepted. Okay, so let me tell you why I am taking count first and then element first. Okay, so in priority queue what happens, that the sorting the sorting is done on the basis of first element, Okay, and in our priority queue, what we want the sorting to be done in count basis. Okay, I don't want the sorting to be in element basis. Okay, I want the sorting to be in count basis. So that's why I have taken count first and then element. Okay, if you don't want to reverse the order, what you can do, you can use a comparator. Okay, you can use a comparator. So you can create your custom comparator, and that will, what will do, it will compare the element whichever you wanted to pass in comparator. Okay, so if you're passing priority queue dot second in comparator, so it will do sorting. It will do sorting on the basis of comparator. Okay, I don't want to write the custom comparator. That's why what I have done, I have reversed the order. Okay, keep remember that. Okay, in case of pairs in priority queue, the sorting is done in first element. Okay, so so insert your elements accordingly. Okay, I hope you understood this point. What I wanted the count of these elements on the priority queue. Okay, so my priority queue looks like 3 comma 1. Okay, then it will have 3 2 comma 2. Okay, then it will have 1 comma 3. Okay, so first element will be the count and second will be the current element. Okay, I have taken this element because I wanted to return the element. I don't want to return the count. Okay, the question demands that I want to return the elements. So that's why what I will do, I will store it in this form, and what it will do, it will return me the count. Okay, it will return me the count. So according to this count, what I can do, I can use that value, okay, associated to the count. So in this, what I have done, it.second in map, it is nothing but the count. So I have pushed count first and then element. Okay, and at the time of erasing, what I am doing, see, pq.top.second contains the, okay, I am writing here pq.top.second contains the element. Okay, and it is nothing but the umap value. Okay, it.first contains the element and it.second contains the count. Okay, so store count here and element here. Okay, so this was working fine. Let me remove this all. Okay, you can put this comment on your code. Okay, so that if you revise, you can understand what is happening. Okay, so you can write it like this: count comma element. Okay, and you can write this umap element comma count. Okay, so that you can understand what is going inside the map and your priority queue. Now what will the time complexity? So unordered map will store all the elements. Okay, it can be at max the size of numbers. Okay, we are not using n, so remove this. And answer will also take key size only. We want to find the top 2 frequent, so it will have 2. If k is 1, answer size will be 1. Okay, so let me write it here. Space complexity will be order of n for map, order of k for answer, and order of k for priority queue also for PQ. Time complexity will be order of n log k, okay, for priority queue. And what we are doing, we are copying this in result also. Okay, so it will be order of k log k for pushing back in answer. Okay, so this is the time and space complexity. And the time for map, okay, it will be nothing but order of n. Okay, so you can plus order of n also. So it is amortized will be order of n log k only. Okay, order of n for this, order of k log k for this. So if you add all of these, it will be maximum will be order of n log k. Okay, so this is all about this problem. Let's move forward to next problem.